everyone, my name's Andy Marshall. Welcome to The Mixer. I'm here with my buddy, my brother from another mother, Dr. Juan Carlos Lopez. How are you, JC?
I'm doing very well, Andy. Very happy to be here, surviving the heat wave that we've been experiencing here in New York, but very excited about this episode of The Mixer.
Great. Well, we really have something to whet your taste buds, the area of diagnostics, and we're talking to a pioneer, Anne Wyllie. Anne is principal investigator and heads up a lab at the Yale School of Public Health. And like many other labs during the pandemic, she pivoted her group to develop a SARS-CoV-2 test. But she took it beyond most other labs with a really interesting twist, I think, which is to use saliva as the sample rather than the dreaded nasopharyngeal swab that we'll be hearing more about during the conversation. And also leads Saliva Direct, which is an initiative that received an emergency use authorization from the FDA for its COVID test during the pandemic. So really looking forward to talking to Anne about her work and where the field of diagnostics is going.
You literally meant it, that it's going to whet my taste buds. So let's get started with the conversation then.
Let's go. So Anne, welcome. We're really delighted for you to come here on the show. We know you're just back from a meeting in Washington all about how spit is going to change the world of healthcare. That's probably the most intriguing lead we've ever had for one of these shows. But seriously, what we wanted to do today was talk about the world of diagnostics and some of the important innovations that are happening in the area. And also, of course, there's been some recent news about changes at the FDA, which I think are going to have a big impact on the field. Obviously, diagnostics is a very, very large area, and we're going to be focusing most on the importance of diagnostics in infectious disease,
Yeah.
For most of the world, diagnostics came front and center 4 years ago when COVID was starting to spread across the world, and that was very important in how your lab and many other labs around the US started to kind of think about how can we perform both diagnostics and surveillance, and that's a whole other area. But maybe if we could start by you telling our audience a little bit about your interest in the area, what led you here, and what are the main themes that you're exploring in your research group at Yale?
Yeah, sure. And thanks again for having me on. It's great to be here. So I have been working with saliva as a sample type for over a decade now. I wouldn't say well over, but over a decade. And that actually started still in the respiratory pathogen world, working on a bacteria called Streptococcus pneumoniae. And we actually found that saliva was used quite commonly at the start of the 1900s to study this bacteria, but that knowledge got lost along the way. So a good number of years revisiting saliva as a sample type, working with it, trying to get it right, validating different qPCR assays on it. And so when the pandemic hit and, there was a phenomenal, as you said, so many labs just pivoted, so many people came together and collaborated to do all that they could in the pandemic response. And that was also done at Yale. It was phenomenal just how many people dropped what they were doing and just tried to contribute any way that they could. And so we were trying to collect samples from COVID-19 inpatients or people in the community who are presenting with respiratory symptoms so that we could try to better understand COVID-19 and SARS-CoV-2 infection. And during that time, we just saw all of the troubles that we were facing with the nasopharyngeal swab. So people didn't quite enjoy having them taken. Healthcare workers weren't enthused about taking two swabs from individuals, one for diagnostics, one for research purposes. And, the gold standard for the detection of SARS-CoV-2 did default to the nasopharyngeal swab just based on what we used for the likes of flu and RSV. And that just meant that the global supply chains collapsed as well. And so having worked with saliva as a sample type for a long time and knowing the benefits of it, but without any idea how it would work for viruses, how it would work for RNA, I still wondered with the team whether it could make a difference. And again, everyone was just so supportive and eager to find solutions to the challenges that we were facing, that we just started testing saliva from COVID-19 patients, SARS-CoV-2 infected individuals, and to validate it as compared to that gold standard nasopharyngeal swab. And yes, by mid-April 2020, we had found that saliva was working really well. So that's what we have continued to work on since.
Yeah, so it's be really interesting, maybe just to provide some context. So obviously, as you're saying, kind of nasopharyngeal swabs have been the kind of standard.
Yes, right.
And in my kind of experience at Nature, obviously we're in the research world, and there was a lot of interest in some of these kind of direct-to-consumer tests that use, saliva, things like 23andMe, where they're testing for hundreds of thousands of markers. And so I've kind of find it puzzling why, saliva hasn't been kind of front and center. Why is it? Can you kind of help us kind of understand why it's kind of only coming to the fore now?
As I mentioned, with pneumococcus, saliva was used pre the antibiotic era. Studies kind of disappeared for a while during that time. I think they thought with the advent of antibiotics, everything was cured. And then when they started doing testing again, they started using the nasopharyngeal swab. So the nasopharyngeal swab has just, for some reason, been the sample type of choice since, around the 1940s, easily. Laboratory processes, clinical processes, hospital processes have all built themselves around this nasopharyngeal swab. It became the gold standard. There wasn't sort of anything else challenging that. Not to a degree that, as we've seen during the pandemic. So there's actually quite a large number of studies that were conducted actually prior to the pandemic that actually, when we dug into the literature, we found evidence for that. So people had been comparing saliva for, say, the detection of influenza, for the detection of RSV, for example, and they actually found really promising results. But one small little research group, maybe in one hospital, that's not really enough to change the conversation with clinicians, people in the lab, the workflows, the full extensive validation that's required. And you really have, I think, a lot of data out there, or the pressure on you to consider other options. It can be hard to make that change at such a scale.
There are all kinds of challenges to bringing innovation, whether it's in the type of sample you're using or the technology that you're trying to introduce, and the way in which the technology is implemented, whether it's in the clinical laboratory or point of care or, even an at-home testing. So could you kind of talk a little bit about, the way you're thinking about these tests for clinical applications, and then maybe beyond that, like for POC and at home?
It has been absolutely remarkable over the last couple of years just to see the increasing enthusiasm for saliva as a sample type, whether that is from those in the labs, those in the clinic, but also from patients themselves. So many people, unfortunately, had to experience the discomfort of a nasopharyngeal swab over the course of the pandemic. So, you now have especially parents coming into sort of pediatric clinics, and when they see that their kids are about to get a nasopharyngeal swab, they do ask if there's alternatives. Can they have a saliva sample? We are also seeing a growing number of studies that are coming out that are finding that saliva can find additional positives that the nasopharyngeal swab misses, or that it performs comparably in certain settings. And I think the transition to remote or unsupervised collection, we already saw that, again, during the pandemic, being able to send kids home with saliva collection kits, being able to mail them out and have these sort of returned by the post or dropped off at their school or daycare centre for weekly testing. It was really ideal for that. So there is a lot of interest in moving towards the point-of-care testing. There are still many challenges with saliva, though, and I think this is what's really impeded some of the development on the point-of-care testing realm, because saliva samples between individuals are so much more different than taking a swab and putting it into a very standardized media. And so the pH of those samples can be very different, the viscosity of those samples, what you've eaten in the last couple of hours. And so all of these can really impact the maybe the lateral flow type assays that we've seen, the LAMP assays that we see. I mean, I remember a great story coming out of the UK where kids realised that they could, instead of taking their mouth swab, which is effectively a saliva sample, if they drank some soda beforehand, they could make their test turn positive so that they could get out of school during those times. So it does just show the sensitivity of these assays to unexpected additions to them. And so it has made the development of point of care assays slower. I wouldn't say that they won't be there. Again, we are working with a non-traditional sample type. We don't have standardized ways of testing with it, processing it. And so many of us are still trying to find out what the best ways of collecting it are, what's the best way of standardizing it for application to different assays. And again, I think having the growing interest from a growing number of fields is going to help drive that development further.
Talking about sensitivity, what is the main challenge then for development of these diagnostics? Is it that there's a large number of false positives or false negatives? I would have thought that by doing it in saliva, as you were somewhat hinting, you are open to a lot of noise. And I'm trying to understand a little better what the limiting step is to improve sensitivity so that they can be used in a more widespread manner.
There's a bit of both the false positives and the false negatives. So if there is something in that sample that triggers a positive response in the absence of what you're actually testing for, that can be a problem. And we got sent a very, very promising assay, a very exciting assay for us to try. This assay was looking great on swabs as a point of care test. And they asked us, they recognized that we had SARS-CoV-2 positive saliva. Could we see what happens if we just entered in some of our samples into this test? And as soon as we added the samples, I think it was about 20 to 30% of the test turned positive without even running the test, without even the time that was required, just because of the variations in these samples and something within them was triggering a positive result. So I think that's sort of where that test got left. I think it did very well with swabs and just didn't continue at all with saliva. I think in terms of sensitivity, what we're seeing with PCR tests, if you have good collection methods, if you aren't diluting your sample unnecessarily, there have been so many tests, so many studies, so many validations where saliva has performed just as well as, and in some cases even better than the nasopharyngeal swab. I think there was a fantastic study that came out and they were using the swab as their reference sample type, and saliva outperformed it. So they're like, this test therefore has a 103% sensitivity because it's outperforming the gold standard. And I thought that was an incredible way of phrasing it, because it just goes to show, what we're seeing from a lot of studies is that, in effect, neither sample type is perfect. That whether it's swabs, whether it's saliva, depending on how it's taken, when it's taken in the infection, how the person has been infected, that there is a risk that one of those samples is not going to perfectly align to the other sample. And, I think sometimes we can't let perfect be the enemy of good enough. And so in terms of it's getting a test out there, especially if it's cheaper, more accessible, or it gives us options, it's a way of surveillance, is sort of recognizing what can we still be adding to our toolbox of testing approaches, that we can make sure that as many people as possible can get tested when they need it, and that we are relatively confident that we are going to be catching, the vast majority of cases in either testing approach.
Correct me if I'm wrong, Anne. I'm presuming that this is very case specific, so certain microbes are going to be more prevalent or last longer in a certain region than they will in another region. So with SARS-CoV-2, for instance, does RNA stick around in the nasopharyngeal location longer than it does in the saliva, or vice versa? Are there, indications that, you really shouldn't use saliva for streptococcal infections, you should use nasopharyngeal? How do we kind of work that out?
That's a very, very important point. So many of us have probably heard over the course of the pandemic of, once you've had a PCR test, maybe you shouldn't get one for another 90 days because you might continue to test positive. When people started doing more, and at one stage I even had a fireman it was sort of early mid-2020, rang me up, and he'd had COVID and he tested positive, and his work wasn't letting him return until he had a negative test. And this was indeed about 30, 40 days on. He's like, I've seen that you've been doing saliva testing. Is it possible that maybe we could double check this with a saliva test? And as more people did comparison studies, longitudinal, constant sampling individuals every couple of days, and even what we sort of saw early on in our study as well is that typically the detection of SARS-CoV-2 would clear faster from the oral cavity versus taking a nasal swab. And, one of the reasons why I think that happens is if you think about if you're eating something, having a drink, just even swallowing saliva from your mouth, you're constantly sloughing liquid food through, you're sloughing off cells, you're clearing things out of that cavity. Whereas, especially in adults, our nasopharynx is drier, it's more keratinized, whereas kids obviously have a lot going on, a lot of things also moving and clearing. Adults less so. And so if you just think you've had this large infection, but the virus itself is no longer replicating, it's no longer infectious, but there's remnant RNA that's trapped within that space, it's going to be a lot slower for those old cells in the nasopharynx to slough off and clear that. And so there's definitely been evidence of that I think we need to be very mindful of when we're interpreting these tests. They can still give us an indication of someone who was infected previously, and so maybe these complications that they're continuing to have 2, 3, 4 weeks on were a cause of that, but they're not necessarily a good indication of someone who's actively positive and even contagious to others during that time. Also, as you recognize, indeed, my being in the realm of pneumococcal research is we look for carriage in both saliva and the nasopharynx. But carriage, this is a bacteria that's considered a commensal. So it's actually been quite a typical part of many of our normal respiratory microbiome. There's been some fascinating studies where they've sequenced the microbiome of a piece of bark that was chewed, and they found the pneumococcus's great-grandmother, I think it was. So this is a bacteria that's evolved alongside us for millennia. So its presence in the upper respiratory tract doesn't necessarily reflect infection. Infection is, if you are then finding it in the lungs or sterile sites where it shouldn't be. So again, it's understanding those things, like when you take these samples, what does it mean? Of course, if it's typically a virus, that would be more indicative of an infection, but of course also understanding how those sample types compare, and indeed which gives us the more sensitive test result at the end.
So one of the things that I think it's important to touch upon is, Andy was alluding to this earlier, the regulatory changes that are being implemented. So what can we expect moving forward for the approval of some of these diagnostics? And once we start seeing approvals, what do you think is going to be the low-hanging fruit for these approaches?
I really recognize the challenges that the FDA faces and the amount of liability that falls on them. So once they authorize a test, just how much data has gone into, or even approving a test, how much data goes into backing that up, and do they have sufficient data, especially on non-traditional sample type or approach, that can really reassure them as to its performance when it goes large in the general public, because this then falls on them. That can obviously be a very difficult situation. Coming from the test developing side, that can be a very frustrating point when we've seen such phenomenal evidence around the world of what we can be doing with saliva as a sample type. And cumulatively, just all the different studies combined, all the different tests combined, recognizing that there's a lot of potential in this. But I think especially as the first saliva-based tests come through the FDA, they're going to obviously be stricter as well to really make sure that they're sitting through a test that's then going to be available as a standard for other tests to compare itself to. That test has to be very reliable in their eyes. I am really excited about the potential for other tests. We've already talked with so many people about having saliva-based tests for strep throat, and how many parents would love that, how many, I think, also children would love that versus the oropharyngeal swab. I think many of our other typical respiratory viruses we will be able to expand into. We did a very, very quick validation study with the very limited number of samples that we had, but we recognized that during the Mpox outbreak in the US a couple of years ago, it was recognized that saliva is a source of transmission for Mpox. And you're like, well, if you're transmitting it, surely you can then detect it. And so we demonstrate that, yes, we could. And again, there's been a growing number of studies coming out from other places that, yes, you can detect Mpox. To that line, we also have a number of people who are really interested in testing STIs in saliva as well. And I think, again, a lot of it's what's really important to recognize is that whether it's Mpox, whether it's STIs, is that it's not meant to replace other options. And it doesn't even have to be offered in isolation. But if you can send out your typical swabs and a saliva sample, you're probably going to be more likely to find an individual, or if the swab doesn't work for some reason, you've got the saliva to back up onto, or just that some people are going to be infected in certain areas and not others. And so I think it'll be really great to be able to see it expand as a complementary tool in some cases, and I'd say just more patient-friendly tool in other cases as well.
Was the plan always to go through the FDA rather than just develop a laboratory clinical test? And the kind of second part to that, because obviously there's a lot of chatter going on. For instance, the American Clinical Laboratory Association, which kind of represents all of the clinical labs, they're not so happy about the fact that the FDA's come out and said, well, we had enforcement discretion before, but now we're basically going to oversee everything.
Yeah.
Can you talk to us a little bit about how you see that and the pros and cons of the FDA overseeing everything and the kind of system we had before, which is maybe for our audience who might not be familiar, it would kind of help to explain to them we had this kind of CLIA-based system where essentially you got accredited as a laboratory to run tests, almost like a service. And then for the kits and the products that are made by kind of commercial manufacturers, you had this kind of other program, yeah? So could you kind of elaborate a little bit about how you view all that and how you're thinking that applies to saliva-based diagnostics?
First of all, we recognised that we needed to go through the FDA. Well, we didn't even recognise, we didn't know. We had to rely on others who were more knowledgeable than we were in that clinical diagnostic space to advise us that that's what we needed to do, because we were an academic research lab. We knew that we had come up with a test. We wanted to make testing as cheap, as easy as possible, as accessible to as many people as possible. And we certainly didn't have the resources or the space or the equipment to start up a large-scale testing operation. And indeed, I don't even know how that would have looked in terms of, as you said, we were not even a CLIA lab. We were not a clinical diagnostic lab. If we had been, we could have done something like that, and that's what many people did, and that's what the flexibility of the current regulations has allowed, that indeed labs can develop their own tests, they can validate them to a high standard so that they can offer them as a diagnostic assay to their communities. So for us, we did have to go through the FDA. The FDA was incredibly collaborative with us because we did something that they've never done or seen before. We didn't want to be making, selling, distributing anything. We just wanted our test protocol to be available for any diagnostic lab to be able to pick it up, take the protocol, order the supplies that they needed directly from the suppliers, use the instruments that they already had in their labs, streamline it, make it cheap for them. We didn't want them buying new instrumentation. We wanted them to utilize their existing supply chains, their customers, maybe discounts that they get from the existing customer relationships that they have. And so no one's done that before and hasn't done that. And so it's going to be really interesting to see as we go full approval how that's going to look. I'm not even sure if the FDA quite knows yet how that might look or not. But if you're thinking about the clinical diagnostic lab, as you mentioned, clinical diagnostic labs at the moment have that ability to take as you said, like a test kit that's designed for something like swabs. And if they said, hey, we think this might work well on saliva, they try it out, they find that they get something as sensitive, it's working as well. And again, these are clinical diagnostic lab people. They are so aware of where their results are going and the impact that this has for their patient populations. They're only going to offer an assay that they also really sure of and how that's going to work, because again, it comes down to a liability thing and also just a moral thing as well. And so at the moment, labs are able to do that. They're able to develop, either shift an existing protocol, apply it to a different sample type. Maybe they come up with a whole new test for a whole new sample type themselves, and they're sort of given that discretion to be able to get it up to a high enough quality to offer it. And I think that's where we see a lot of innovation lie. You have the studies, the reports come out of it. You can find some labs that have tests available to their communities that just aren't available elsewhere, or maybe you hear about that it might not be available everywhere, but what if that's a test that you really need? Whether you need it for yourself or your family to really figure out what's going on with you. And I don't know how the FDA expects that to look if they have, as you said, that greater oversight. Asking the labs to bring each of these tests to the FDA takes so much time, it takes so much money, it takes so much work. That's work that's subtracting from your normal laboratory business. Do people have the bandwidth for that? Does that in the end mean that labs will have to offer a smaller menu? And does that sometimes then mean that there are going to be individuals that receive a lesser standard of care than they would have been because that test that could have been offered to really help them is no longer available because these labs aren't able to offer something that they've validated to be really reliable and that they're confident on, but because of the regulations, they can no longer do so.
It's a real quandary, isn't it? Because on the one hand, in many cases, these are kind of aids to clinical decision making. It's not like be all and end all.
Yeah.
And I think the FDA is trying to accommodate the fact that some tests, there's very little risk involved, and then other tests, for instance, we haven't really talked about it much, but the area of precision medicine where you have a companion diagnostic that's going to tell you which patients will respond and which won't respond. Yeah. That's a really important decision that's going to really have an impact on, a patient and clinical outcomes. And so in such a case, you can see there's a very strong argument, yeah?
You could see the flip side on it, where if the FDA somehow made it cheaper or easier for a lab to bring that laboratory-developed test or LDT to them, and that if they were able to receive some sort of broader clearance for it and has suddenly made this test more widely available to others, which is sort of the typical approval process at the moment. But again, the resources that it requires. But if there was a way that became an easier, it was a less burden approach to take, it could also be incredible that if other labs could then go, hey, now we know of this test that could be really great to offer. We can leverage some of the validation work that's already been done. The FDA has also screened it and cleared it or something. But I think just finding a way that incentivizes labs to take that to them to help them get it out there. But I'm, again, not sure at the moment what sort of plans are in place for that and how feasible that's going to be.
At some point you were alluding to the market, right? And to how difficult it really is to bring these products to market and how costly it is. And it's somewhat paradoxical because it would seem to me that one of the greatest opportunities for this would be the market in developing countries, right? Particularly for infectious diseases. You would have thought that it would make a lot of sense for surveillance to make these diagnostic tools available in low and middle income countries where a lot of these pandemics can start, and there's always the need for these kind of diagnostics. And I'm kind of wondering if there's any initiatives that are looking into making sure that these countries get access to these diagnostics, or if that's an area where we need to pay more attention.
That's something that I've been incredibly focused on as well. I mean, especially, again, we developed an assay that takes out most of the necessary reagents. It can be used on very standard PCR instruments. Of course, yes, a PCR instrument is still a laboratory-based equipment, but instead of some of these highly technical, highly specialized pieces of equipment that can only be used for a limited number of assays, PCR instrument is still more broad than that. So I would love to see, especially indeed the expansion of diagnostic assays that we've had over the pandemic. If we could see more of these make their way into settings where we recognize that surveillance would be greater, the idea that we can get them into remote communities to make even screening easier. I mean, we've been talking about, say, for example, testing saliva for TB, and some suggestions, is that 80% is sensitive, but even though it was 80% compared to sputum, there's a large number of people who can't produce sputum. But if you also had some sort of POC test out there that could deal with saliva, but not sputum, in 80% of your infected individuals, you were able to identify them there on the spot. You didn't lose them to follow up. Those who are negative, you don't need to clear them as fully negative. You could be like, okay, you're negative on this test, but we'll take your sputum or your other sample back to the lab elsewhere. you could be diagnosing and following up with people a lot faster, a lot more easier. One of the challenges comes down to is that a lot of these international settings and a lot of the groups who are looking to support these, I mean, obviously the Gates has been doing a phenomenal effort in trying to, support studies, support research, support development. Find is another agency that's been working hard in this field. But a lot of these, and also international governments, healthcare systems, they look at the FDA, what the FDA has authorized, they look at what the US CDC says, they look at what the WHO says. So in our case, for saliva, whether it's saliva as a sample type or Saliva Direct, which we developed, we do need to get that full authorization for it to get onto the WHO list. The CDC, unfortunately, had a bad experience with saliva as a sample type, so there's been some not very encouraging language on their website. But then other countries look at that, and it's just a bit, how can we improve this sharing of data about how beneficial these different tests can be in different settings, and how can we actually get them into the places where they can be most helpful. Having to get through the FDA, even though with our Saliva Direct assay, we've probably well over 8 million tests have been conducted around the US. It's, supported schools and workplaces. But now we might have to do a formal clinical study, which may cost well over $1 million. And, we've done all this at no cost to communities, at no cost to labs throughout the course of the pandemic. That quite the large burden. And this goes for any other lab who has to take their LD through the FDA. If you're talking about doing a $1 million validation, that already rules so many people out. So again, it's come down to how can we make that step easier so that if we do want to have more tests out and through and available, that we can get those ones that can really make a difference into the communities who need them.
I heard Alex Greninger at University of Washington talk about COVID testing and surveillance. He said that, we're in this kind of post-COVID hangover.
Yes.
And it's kind of interesting, a lot of the antigen tests don't really work anymore for the kind of post-Omicron strains.
Yeah.
And I remember when I was at Nature Biotech, I was writing these editorials about this is going to change the face of the way we do surveillance and diagnostic testing. And 4 years ago, there was a lot of kind of excitement about where we would be and how prepared and overhauled the public health system would be in the US, like in 2024.
Yeah.
And I don't know, it feels like we haven't really got too much in terms of pandemic preparedness, and surveillance and having everything in place. How do you see where we are? And why do you think that we really haven't made too many steps forward in terms of public health and surveillance?
You're right. It's been a bit frustrating, a bit disheartening to see at times. I mean, so many of the conferences that we go to, they're peppered with talks on, the lessons that we learned from the pandemic, the lessons that we've learned from this outbreak response. And, it's one thing learning the lessons, but it's a whole other thing to put those lessons that we've learned into place. And indeed, as you said, how to make public health stronger, how to make testing stronger. I think we had a little taste of it during the Mpox outbreak. I mean, we could have made test availability a lot more broader. We could have, there could have been more openness to alternative sample types under, there's so many times that you have the caveat of this test isn't fully cleared, therefore if it's negative, you're not necessarily negative, but if you're positive, chances are you are, and at least we've been able to find you that way. There's opportunities to have that out. And then I think what we're seeing at the moment with H5N1, I mean, just the amount of testing that we should potentially be doing. I mean, the FDA, for example, can consider already putting an emergency use authorization into place. I mean, doing so would incentivize labs, or not incentivize, encourage labs, encourage researchers to come up with a test which right now might not be perfect for whatever strain should ever circulate among humans. But at least it would be a way to start developing something that once we know of a final strain, should it arise, that transmits between humans, that we could rapidly update a test. It would have emergency use authorization. We could get it out. We could get it out there to labs around the country, or even just labs around the communities that are being affected, to respond more quickly. There's a lot more that we could be trying to do in terms of even just screening individuals at the moment. And I don't know how many more outbreaks or scares it's going to have to take for that to happen. And, how much is just also driven by, but as you said, the fatigue is a real thing. So many of the labs or the academic groups that industries that pivoted during the pandemic, they pivoted away from their normal business, their normal research. And of course, many of them have wanted to go back to what they were set up to do, what they wanted to do. A lot of them were sort of turnkey or startup labs that have since shut their doors because, the market's not there. And so it really takes those who continue to see the need for it or continue to be supported to be invested in it as well. I mean, and this also comes down to, as we're saying, research funding to make it possible, investments to make it possible. There needs to be a source of support for those who are dedicated to doing the work to be able to support them to do so, because without that, that's where you're also going to find that people have to pivot back out of it to find the avenues that can support their work instead. So, I think there's a number of things that go into it. It is so encouraging when you find the little pockets of individuals who are still so dedicated to driving forward on what we've learned so far and trying to push forward the development. Yes, it's slowing it because there's not as many people who are working on it, but it is still really encouraging to know that there are still a good number of those who are still interested in it and also ready to scale up, should and when it be needed.
In the context of what you just said, what really excites me about Saliva Direct is that you are taking a kind of different approach, to the business model of how one approaches diagnostics. Because if we're fair about this, essentially the business model is broken.
Yeah.
People talk about diagnostics being the ugly stepchild of biomedicine. Essentially you have very low margins, there's problems with lots of low quality tests kind of competing with any kind of new entrant, very easy entrance into the market. As we've talked about, you need to carry out these expensive clinical trials to convince the FDA that you have the relative sensitivity and selectivity for your test. And then there's the problem of getting reimbursed, and then there's getting the right code. And that has all of these kind of layers of, are you retesting or are you just doing the test once? And are you going to get reimbursed if you do the test again? This is a real kind of complex layer cake of a problem. When I look at kind of Saliva Direct and, you talked about that you've carried out hundreds of thousands of millions of tests. Yeah. So how many labs do you now have in the Saliva Direct network?
So since August 2020, we have designated over 200 labs across the US to test under the Saliva Direct EUA. Obviously, as I mentioned, with labs scaling down at times, closing their doors, some go into hibernation. We have an active network of about 120 labs across the country who are still testing, but those, we still are in touch with many of the other partners who have either sort of gone into this hibernation option or those who have even just reached out and connected with us at some stage. So we have a lot of other academic or industry partners who are just very interested in being part of this broader network as well.
And the IP is essentially open source here, yeah?
Yeah, it is. So, we wanted to make this really accessible. So technically our product under the FDA's eyes is our protocol itself. So we're the only EUA that doesn't have the full protocol on the website. But in saying that, we've published on what we've done. I actually just found it's actually June 16th, 2020, we put our very first protocol of Saliva Direct online on protocols.io. Before that, we were sharing it in a Google Doc broadly with anyone who was interested. So it's very streamlined. We've been very open with it. The very full IFU, if you want to run it per the FDA, is we share that with designated labs, but we've been very open and collaborative with anyone else who's interested in this in terms of research purposes or just understanding sort of different options they can have with testing saliva.
Talk a little bit about what the financial model is. How do you support this? What are the labs who are in your network? What's the economic model here? How are they paying you for being part of the network and doing the test?
They're not. So this was one of our things from the get-go, was that we knew the behind the scenes of how cheap testing could be. But we knew, and we saw on the other side, how much some labs were charging because there was such demand for testing, or recognizing how much they were able to seek reimbursement for. So we wanted to remove as much cost as possible from the tests so that labs could offer it as cheaply as possible. So a number of labs offered it to support schools who are reopening, daycares, workplaces, Broadway, sports leagues, the National Basketball Association. So we had some labs that recognised that this test was so cheap for them to run that because of all the reimbursements they're getting from their other testing, they could actually offer Saliva Direct free to their local communities. And, we've sort of played with the idea, do we charge labs $1 per test because it's really so cheap? That would have been wonderful to keep the lab very, very well funded going forward. But because we were so invested in bringing the cost down on testing, we knew that any cost that or any charge that we made to labs, that cost would be passed over to the patients or the communities themselves. And that's what we didn't want to do. So our first very unexpected research support did come from the National Basketball Association. So it was very surreal to receive an email from the NBA. But they saw that what we'd been doing with Saliva, they were also very keen to find a solution to help not only support the Orlando bubble and keep basketball going, but the idea of could they support something that would have greater community impact, that could actually get out there and be used by others, that wasn't just a highly expensive proprietary test, but could help sort of disrupt what was being done as well. So their support was fantastic. We have received support from NIH RADx over the last couple of years as well. So we have had sort of research support, which has been really great for funding the activities to date. Tempest Labs also gave us a research grant that really helped us be able to create those at-home collection kits and the direct-to-consumer collection kits as well. But to date, we haven't charged the labs, we haven't charged patients. We have spun out to be a non-profit organisation, which again we did with the intention of showing the lab network that we're remaining true to our intentions to begin with. And we are just now trying to find ways to make sure that we'll remain a sustainable organisation going forward. So whether that's through additional research grants, whether there's individuals who are interested in donating, or if there's other collaborations that we can do to sort of help, support the overall organisation as well.
I also heard that there was this kind of idea of vending machines. Mm-hmm. How would that work?
Yeah, no, so that's actually, again, an example of you touched on this lab network, it's been phenomenal. I just didn't expect this insane collaborative network to evolve around a test, but for a while we were having calls twice a week, then weekly, just sharing updates. Again, recognizing that I came from an academic research lab, I didn't actually really know what it was like in the clinical diagnostic setting, and so it was a way for labs to talk to each other, to say what they were seeing as well, to ask for advice or to troubleshoot. And, a number of labs that they came to us just so also overwhelmed that they've never had a network like that. They often would operate in their silos, but these little small labs and little small regional areas could now just sort of network and talk to a number of other labs. So through that, we have worked on validating different approaches. So when one of those, should someone in the lab network have a PCR instrument they want to use that wasn't on our protocol, we can do these bridging studies with them. We can submit that data to the FDA, and that we can expand the protocol to encompass what they have in their lab. And so we've done over 25 amendments to our EUA over the past few years to make as sort of flexible as possible. And this is where the vending machine came in, because we have the at-home collection kits, the direct-to-consumer kits, and there's been some others who have also sort of set vending machines up in colleges around the country or other communities. But one of our really collaborative partners has been Santiam Hospital. They've done phenomenal testing programs for especially the underserved communities in their local area. And so Sarah Comstock there really recognised that if you could get the vending machines out into some of these communities where people, they might not, we actually asked them, as we started validating this, we actually asked them, do you have a PCP? Do you know where you can go to test? What would you do if this wasn't here? And so many of them, they have to work during hours where the doctor's office is open. They don't have a PCP. And so the idea of having a vending machine in that setting really allowed them to access testing that they wouldn't have been able to have before. And that was just our test for SARS-CoV-2. But, as I recognise, if we can expand this out, either ourselves or in collaboration with others or others on their own, but for the likes of STIs or strep throat, or there's some fascinating work being done with saliva for concussion or cancer biomarkers. Can we make sort of general health screening more accessible to those who find it really hard to access the clinic at times.
You have a feeling that this really is expanding out in all kinds of different directions.
Yeah, it really is. The first meeting that we held back in 2021, it was really to try and solidify that network that we had built, to get people together, to meet each other in person after, so many Zoom calls or Google forums or frantic emails. And so that was really quite a almost Saliva Direct showcase. It was like talking to each of the different labs, how they pivoted, their experiences, their lessons, their hopes for the future. And then we held our second meeting in New Orleans last year, and we didn't want it to be all about Saliva Direct, but again, thinking about people who are looking into either sustainable or accessible testing solutions. Mark Johnson joined, who's done phenomenal screening of wastewater around the country and finding all sorts of really mysterious variants in the wastewater. Like, his talk is phenomenal. Others who indeed have been working on either the antibody side of things. Last year was particularly about expanding for other respiratory pathogens. So really wondering where we would go to this year in our third meeting, but especially Brittany Choate, the program manager at Saliva Direct, she pulled together such a phenomenal program where they're talking about funding opportunities, which, as we discussed, have been quite important. But indeed, the array of, again, thinking about strep throat, concussion, cancer biomarkers, again, other respiratory pathogens, and a number of people who hadn't been to our meetings before. And then for them to acknowledge that they've never been in a room, even though they study saliva as a sample type or they're looking into ways that they can use it, that they've never heard saliva said so many times over the course of a couple of days, and the fact that they were really excited about it. And it just led to this very collegial atmosphere. Everyone was you just basically couldn't get people stopping talking to each other. And I think it's just, recognizing that there are a number of us with shared interests out there, and it's a very collegial, collaborative space, trying to, lift each other up with the knowledge that we've each gained or the experiences that we've had, rather than competing within a certain space. Very, very inspiring event, and we're already excited about thinking about the next one.
You and I, Andy, think a lot about therapeutics, and we understand the model. And you already alluded to the fact that the model for diagnostics tends to be, it's very different. It's volume, and it's often neglected. I'm wondering if you have much support from your institution when you come up with an idea for commercializing a diagnostic. Or is that an idea that academic institutions are not that supportive just because they know that the margins are different and they get much more enthusiastic about therapeutics than diagnostics?
I hadn't actually worked within that space prior to the pandemic, and I must say that Yale did some really, really great agreements in terms of how they'd be sharing sort of technology that came out and making it available to the public. And I only worked with Yale Ventures for the first time through this. I also worked with our regulatory support at the Yale Center for Clinical Investigation, Amy Hummel, and Amy and Lola, who I worked with from Yale Ventures. I couldn't have done any of this without them. I'm not trained in business negotiations by any means, or I am an academic researcher. You put me in front of anyone, I'm going to ramble about the science and probably, miss a lot of the important talking or economic points that I just hadn't really thought of. I'm going to get super enthusiastic about the smallest detail that really probably won't change much of the discussion. So especially working with Lola, having her support through so many different, just how to get word of the test out there, how to talk to laboratory partners who are interested but were unsure of the model, unsure of how it would look, and indeed having to go through the regulatory process and thinking about how we were going to market something that there wasn't really much there to actually market, but the support from Yale Ventures and Amy on the regulatory side just couldn't have done without, and just incredibly thankful for their support through so much of this.
Do you think that the model that you've come up with here for Saliva Direct is a model that others could build upon? And have you seen that happening at all?
There's interest in it. I would really love to see it built upon. So whether, first and foremost, leverage the network we already have. If you've already got all these labs who know and are interested in working together or can see the value in coming together to provide a solution. One of the things that we just very try to make aware is that if anyone out there has an idea, wants to get something out, definitely come and talk to us. Or exactly the thing is, when we tried to adapt the test, or when we adapted the test for Mpox, it would have been phenomenal to get that out for Mpox response to 200 labs around the country. So yeah, I'm really hoping that people will see the value I hope we don't really have to test that through some sort of H5N1 epidemic outbreak. But the idea is the same thing. Like, if you can get a test out there really quickly to different areas, we saw the problems of having one or two, massive sentinel labs in certain sites that just filled up with testing. I mean, we know that we don't want and can't wait for 14 days for a test result when it becomes irrelevant, or a snowstorm hits and none of the tests can make it to the lab. We had labs who were supporting schools and they'd drop off samples in the morning and have them same day afternoon. I mean, Broadway was having samples taken the night before so they'd have all their results in the morning before they got together and safely unmask. So we've seen the power of what local community labs can do, especially if we're supporting those community labs. It's supporting the local economies, it's supporting the workforces there, getting maybe more local buy-in, which I think is the same model that should apply internationally. If we can make, even though it's a test that may be developed internationally, if local communities internationally can source the reagents, the supplies that they need locally as well, again, that's going to support their local economies. They're not going to be subject to supply chain disruptions, say from the US or from Europe. I think those are the models that we do need to be looking at. Whether we take this national model and do try to expand it internationally, I think also having that avenue for communication for what people are seeing, the way to troubleshoot, the way to alert people faster as to things we're saying, I think it should be really considered to strengthen our public health responses when we need it.
So, JC, do you have a last question?
Yeah, no, the traditional question, right? So before we started recording, Andrew, you were already telling us a little bit about your favorite drink. So why don't you elaborate on what it is and the history you were telling us about it?
Well, first of all, actually, with today being my birthday, actually, as a true Gemini, I do typically like...
Happy birthday.
I do typically like to try anything new and different on a menu. But failing that, my go-to is either a spicy margarita at the moment for some reason, or I was going to say a good classic gin and tonic. But again, being this Gemini that I am, if there's some sort of different or new or local gin that I can try in that, I'm going to do that first. A G&T would be up there for me.
Very good. It's one of the most, modest cocktails in the sense that it's very easy to prepare. I'm sure even Andy can prepare one.
Hopefully.
But actually, I shared your enthusiasm for gins. Every time I travel, I try to bring back a bottle from wherever I go. I was just in China, and in China they don't really have gins. But I flew via Japan, and so I managed to get a few bottles from there. They have very nice gins over there.
Yeah, Roku is one of my favorite, but also, so I was saying, earlier, I'm drinking one that's distilled on Great Barrier Island, which is an island off Auckland, New Zealand. But I also discovered this incredible gin in Uruguay over Christmas, which now that I'm getting to the bottom of the bottle makes me quite sad because I don't know how to get this otherwise, but it's such a great gin.
Well, Anne, this has been really fascinating. I mean, it's an incredibly complex area to kind of get your head around. There's all kinds of challenges, but incredibly important that we solve. Kudos to you for all that you've done in this area. I think it's going to be really important for the field kind of going forward. And thank you so much for coming on the podcast on your birthday. We had no idea.
Yeah, that's very generous of you. Thank you.
Oh, it gave me an excuse to have a G&T, right? So,
yeah. Well, happy birthday. Thanks so much.
Thank you.
Cheers.
Bye.
Well, Andy, that ended on a high note because talking about gins, as you were saying at the beginning, it really whets my taste buds. But I must say that this whole topic is quite interesting. It's one of these areas that we seldom talk about, and there's a lot of activity that we're just unaware of. One thing that I really liked about this conversation was that it illustrated quite well some of the points that we heard last month from Veronique about open science. How is it that this community has really come together to share their experience for the common good, and they have not let traditional obstacles like IP and company creation and all of these things that are of increasing interest to academic institutions, they haven't let any of that get on the way of progress. So to me, it was very refreshing to see an actual practical example of what we heard last month. And I think Anne is a very prominent standard bearer in that field.
Yeah, I couldn't agree more. I mean, you wouldn't really put diagnostics together with open science. It's not something that's really come across my radar, but
No.
I think this is really a case of that. And it works, yeah. I really like the model Anne chose for Saliva Direct. She's not swimming against the stream of investment, reimbursement, regulatory and distribution challenges. She's swimming with the stream that can rapidly get tests out to clinics and even to people in lower to middle income countries. Yeah. To me, I really liked this model of, getting the FDA to authorize a protocol and then distributing that out to labs that then feed in their little nuances and changes to the test and, refine and optimize it as a community. I find diagnostics to be an area that really needs something like this, a technology for democratizing access. And we talked during the conversation about the kind of hangover that there's been after COVID. As I think we need new complementary solutions to the traditional ways in which diagnostics have been used, whether it's in the clinic or whether it's point of care or whether it's, in the community. How are we going to create new mechanisms to deal with emerging pathogens that are inevitably going to come our way? So I found this whole conversation really interesting.
Yeah, I mean, let's think about surveillance, right? It's the sort of thing that we are always hearing about. And in this case, to have such a simple protocol for surveillance in low and middle income countries, which is where a lot of these emerging pathogens come from, it would be quite positive. It would be cheaper, and politicians may be more receptive to funding this kind of work because it wouldn't be too cost intensive.
Right.
So I must say that also I was very pleased to see that Anne was partial to the gin and tonic. Mm-hmm. So as I was saying, a very, very simple cocktail to make. And, to make it a little more interesting for our listeners, we'll put down in the description below the basic specs for a gin and tonic, but then we'll also throw in a variation of the gin and tonic that I personally like a lot called the Mediterranean Gin and Tonic, which involves a couple other ingredients, and it's very good. It's the one that whenever I see it at a bar, that's the one I order.
Actually, G&Ts were my uncle's favorite tipple. I always kind of think of gin and tonics as being old school now, kind of having a gin and tonic at the end of the day in the club.
Oh, really?
Anyway, this was a really informative conversation. I think really enjoyed it. Thank you, JC, for your inputs. Thank you to Anne, of course, who was joining on her birthday. Happy birthday, Anne. And thank you to you, our listener. And we'll look forward to seeing you next time. Cheers, JC.
Cheers, Andy. See you next time.